Hello everyone and welcome to our today's session of Dockers and containers. So we have developed a small Python code in a very simple way so that it is easy to understand for everyone out here. If you have even a slight understanding of how Dockers and containers work. Here today we are going to understand not only Dockers and containers but a little bit about Kubernetes, and also we'll talk about message brokers. In our example, we are going to use MQTT. MQTT is nothing but a pub sub model, publish and subscribe model. Why we are using MQTT? Because it is a lightweight method for messaging, and we thought for this example it would be best to use MQTT. Though there are also varieties like RabbitMQ is there, Kafka is there, but we chose for MQTT. So let's start. In this exercise, how the flow would be: on the AWS, we are going to create an Ec2 instance. On the Ec2 instance, we are going to install Docker and Docker Compose images. And I'll show you both the examples. We'll create an image from Docker, and also we'll create an image and container from Docker Compose. After we create the images and create the containers, we'll deploy our code over there on the Ec2 instance. It's a Python code. That Python code will actually connect to a device, which is nothing but an ICU. ICU is in a hospital. If a patient is admitted into an ICU, you require a real-time monitoring of the patient's health statistics. And there are various sensors that are connected over there in the ICU room. And those sensors will pass down some information in a real-time manner onto our AWS cloud. And from there, it will pass down to our message broker. From message broker, these messages or these live data will get stored into DynamoDB. Now, DynamoDB will store this on the based on timestamps. Every second, millisecond, the data will keep publishing consistently onto DynamoDB. And that's what the entire flow we are going to look at into this exercise. Before we proceed to the live example, let's have a little bit of quick understanding on how Dockers and containers work, and a bit of understanding on what Kubernetes. So today's modern world is all about speed and data. When we talk about data, that means we need more and more capacity to store large amount of data. It could be a real-time data, or it could be a batch-wise data. And when we talk about speed, we need a lot of memory to process the system faster and faster, especially in banking. However, both of these comes with a lot of cost. There's a lot of huge costs associated with that. Now, which means that we need to optimally plan our capacity and memory. Now, that means we have to either reduce the capacity when it is not required, or increase the capacity when it is required. And this notion of adding and removing the capacity is called scaling. Now, scaling, you cannot always have manually. You can keep a trace of it. In large organizations, you have a lot of virtual machines, into play. And if we are having, let's say, 100 virtual machines, how are you going to keep a track of which machine requires how much amount of memory, or what capacity, what systems are going to process what level or amount of data? It's highly impossible or difficult to do that unless you have a huge army to sit behind the scenes and do that work for you. But that also comes with a cost. So how do we deal with this problem? And that's where Dockers come into the play. If you remember the concept of OOPS, if you go back a little behind the time, when OOPS started, so OOPS is all about classes and objects. One class, you can initiate multiple objects. If you look at Dockers, it is all about images and containers. In one image, you can spin off multiple containers, and multiple containers can run on one virtual machine. And that also comes with some allocated memory and capacity. However, before we move ahead, let's understand a bit more about that. So every virtual machine may have Docker installed. But does an organization have only one virtual machine with one Docker installed? No, it could have hundreds or maybe 200 virtual machines. How do we deal with that? How do we manage all the Docker daemons that are sitting into each and every virtual machine? A daemon for a particular virtual machine is totally isolated to that machine. A daemon in one virtual machine will not know or have a visibility of what's going on in the other virtual machine. How do we deal with that? If there are 100 virtual machines, how are you going to take care of it? How are you going to execute the command saying that here I want to start the service, stop the service? How will you trigger that? And that is where Kubernetes comes into play. So Kubernetes sits on top of the daemon, the Docker daemon, and Kubernetes controls and manages all of the 100 machines. So Kubernetes tells you, okay, you don't have to worry about all of this. I'll take care of you. I'll manage all the virtual machines for you. I know what to start. I know how much capacity each container will require in each of the virtual machines. And this specification of how much memory, how much capacity should be allocated to every container or each container or a group of containers in every virtual machine is stored in Kubernetes in the form of pods. And in the concept of AWS, these pods are nothing but we'll call this as tasks. Let's begin with the exercise. So first of all, let's understand the Python code that we have written and created for this example. So if you see here, we have created two codes. One is the ICU monitor 1 and ICU monitor 2. Like I mentioned earlier, we are going to use an example of a ICU device, the sensors in an ICU room in an hospital. Now these functions that we have created are in Python, and we are using a library called MQTT client library. Also, as I said, we are using the Mosquito brokers, that is the MQTT brokers, to send the message to send a message down and store it in the DynamoDB. Here we have used simple callback functions. These functions are also available as an example on Google or AWS documentation, so you can go and check that. It will be available. Just to have a quick understanding, so these are callback functions that we are using over here, and this callback function is passed an argument below in another function that will trigger an event to this function, and then it starts connecting the client IP address is nothing but a broker IP address that we use to connect, and there are flags that is defined. So these are the 4 default parameters you can use. You may choose to have this RC. These are return codes. There are various return codes that are used in these functions, and based on these return codes, you can check your connection, whether it is a connection successful as a 0 return code or connection refused as a return code 1. Based on that, you can check and implement over here. If a return code is equal to 0, then what action you take, and if it is so and so likewise. You can set the flag as default to false to check, that when every time the code runs, the flag is always defaulted to false. And once the connection is established, you can change the flag to true. One thing that important thing to note over here is that once you connect, there is also a parameter for sleep that we have defined over here in the function. Now this is very important thing to note. Remember, when you establish a connection to the MQTT broker, your code should wait until the connection is established. It should not time out, and that is why we are defining a sleep over here. Now, like I said, you can invoke the flag over here to check whether the flag is false or true, but definitely make sure that you have a sleep time over here in your code. So this is basically a code that we have written to establish, detect the sensors, get the data from the sensor, and then we have written a simple massaging script that will take the message and store the message into a DynamoDB database. One point to note over here, we have created a JSON over here, is a configuration. Now this JSON is actually calling, we have created 3 types of sensors to take the body temperature and the oxygen and the carbon dioxide levels. And we have defined the frequency in this JSON file. There is a standard value, so these values are to set the rules, the business rules and criteria. If the temperature is going above 99%, then it should actually give me an alert on the patient's vital signs. Likewise for these sensor type of oxygen and carbon dioxide. And then we have defined a standard deviation value. So this standard deviation value we have used so that the temperature on a daily basis should be within 1 standard deviation or 1.5 standard deviation from the daily mean. That's the difference that we have just defined over here. And in the code over here, we have just called the JSON. If you notice, we have opened the file and we are calling a JSON file to check and read. And once you load it, it goes through each and every, in the loop, it goes through every devices to check each of the parameters. And then the actual function does the work. You can go through this code. We'll also publish the GitHub link, and you can feel free to download the code, and you can actually use this code, run and execute on your AWS. Likewise, same code for monitor 2. And we have another third Python file that we have written is for MQTT. So here we are storing the data from MQTT device from the message brokers. We are connecting to the message brokers, again using the same callback functions. And then we are storing that data into the DynamoDB. So we'll be creating the DynamoDB table. I'll show you in an example when we execute that. Once we make a connection, we store it into the table, and we are going to create this schema, monitor ICU data as a schema. And within that, we are going to create the fields that we need to store the data. So that's on the code. And let's start over on the example. So let's begin by creating our Ec2 instance first. We are going to go to Ec2 managed services on AWS. We'll create our instance, and we'll give some name to our instance by clicking launch instance. You can give any name, but however, remember to follow the standard naming conventions if you're going to spin up multiple Ec2 instances, whether you're creating an Ubuntu or an Amazon Linux instance. We are not going to give any tags, but tagging is important in case if you are using load balancers and you have multiple container instances. We need to create a key pair. Every instance will have a key pair. Make sure to store this key pair safely. And if you lose this key pair, you cannot, there's no way you can restore it back. So please make sure you have this stored in some of the repositories. So EC2 instance is ready now. We'll go to IAM and create roles. In this role, what we are going to do is we need this role to create certain policies. And these policies are nothing but these EC2 instance should have a permission to connect to our DynamoDB, where we are going to store our data. Then it should also need to have a permission to connect to various other instances or repositories if at all we are using. However, in our example, we are only going to use DynamoDB, so we'll just assign that policy as a Dynamo full access. That's where our role is ready. In security groups, we'll assign the role to our EC2. So that means we have now assigned our EC2 role to our EC2 instance, which means this EC2 instance now has access to DynamoDB. So any data that we are going to execute or any script that we are going to execute on this container instance on these particular EC2 machine will actually flow into DynamoDB. We have to assign 400 permissions because it only needs to be a read-only permission to this key. As I said, please make sure you store this key safely somewhere in a repository. We'll connect to our Ubuntu using SSH using the public IP of the EC2 instance. We are connected to our session now. These are the standard set of commands that you will find on AWS documentation as well for EC2. You can follow that and it's very easy to follow the instructions over there. We are just running the standard set of commands on our EC2 instance to update the libraries or install the libraries that we are going to use. We are only going to use a few libraries which is for MQTT brokers. We are going to use Boto3. Boto3 is required for Python to connect to DynamoDB. Without that, you cannot connect to DynamoDB. Then we are going to use the PAHO MQTT client, which we are going to use. As I mentioned, we are going to use MQTT broker, which is a lightweight broker messaging. We are executing this command so that we can assign Ubuntu user to a Docker group. If you see when I run a version, it only shows me client. Now after I assign the user to the group and I run the version, you'll be able to see that it shows both client and server versions, right? Because we now have the user has a permission into that Docker group. I create a directory over here, separate directory called Mosquito. And in that Mosquito, we're going to create 3 more directories, which is config, data, and logs. Now this we are trying to do with a method using Docker Compose. Remember if I mentioned Docker Compose and Docker. So we'll use two concepts to create our containers. Docker Compose is used, now what's the difference between Docker and Docker Compose? So Docker you can spin up one container, but with Docker Compose, you can leverage the YAML file where you can spin up multiple containers. So that's the only difference, and both have a different set of commands. Again, you will find it on the Docker website itself. And we are just going to use the same commands to spin up our images and containers. So we have installed Docker. Now this YML, we have created a YML file. We'll just copy the contents from the file that we have created. This includes just the volumes, the port details. And this is going to be called when we are actually, so image name we have given it as Eclipse Mosquito, and this will be called every time when we run the Docker Compose command. It goes and reads this YAML file when it executes, any command executes. We are bringing up the Docker Compose and you can see container shows exited status. Let me go to config. We need to create a configuration file. So I'll first delete all the containers that got created. So by using the container ID, if you, this 75 is nothing but the beginning name of the container ID. So Docker just identifies a unique pattern. If you just give two characters, first two characters, it will run your command. So I've created a config file, and now let's try it. Okay, so we have created the container, and here it's up and running now. You can see the container ID, the different ID, and you'll see, notice the name. It gives unique container names automatically, and this will be funny names sometimes. I'll launch another terminal window and SSH into the same EC2 instance using another terminal window. We are going to use our public IP address and connect to that session. What did I miss? Okay. I forgot to use the key, the SSH key that get created key there. So use no. Oh, okay. The command is wrong. I forgot to give -i. So now we are connected to our EC2 instance from another terminal window. We are using the same instance. We have not created multiple instances. Why I'm doing that is to show you how we publish the message and how we subscribe to a message, right? So here we are going to use our mosquito pub command, and -t is to create topic. We are using device/ICU monitor1 as our topic, and we'll just publish some simple message as a hello test message, right? Now before I execute this, let me go back to my first terminal, and here what I'm going to do is I'm going to subscribe to this topic using this _sub command on the same topic that I'm going to publish, ICU monitor 1, and I'll run it. Now it is waiting for a message. Now the moment I hit enter, if you see, the message appears over there. So that means our pub sub is working fine on the EC2 instance. So this is our container ID. We'll stop this and we'll delete this ID. You notice again I'm just giving 5A, which is just the beginning two characters of the container ID on the top. So it's clear. Now so that was what we did using Docker Compose. Now we'll just do using Docker run. And you'll have to assign on the command line. We'll just use the prompt to do that. -p is for defining the port, V is for volume. So what we are doing is that we are assigning this path to this configuration file. That's what we are doing. This is the package image name. Here, so we have our container running, and notice this is a different container ID. And check the name loving_wu. As I said, they give some funny names automatically. So we'll try it out again. So we'll use a mosquito sub command and subscribe to the topic, and I'll again run a publish command over here, and you can see it still works. So we tried two methods of pub sub using Docker Compose and using Docker. So both are working fine. So till here you can try out this exercise. It will work for you. Nothing else is required over here, except the configuration files that will all anyways share over here, and you can very easily see on the screen. Now the next part, we'll publish these messages into DynamoDB. So I'll create a folder, separate folder, and there I'll create a separate file. If you remember, in the beginning I showed you the Python file that we had created, the ICU monitor 1 and ICU monitor 2. So what we are going to do is we'll create separate directory and we'll store this Python file onto our EC2 instance, which means we are going to deploy this in our EC2 container instance. And from here we'll execute these Python files from the EC2 instance, and from there it will go in, the data will go publish onto our topics, and it will get stored into DynamoDB. So that's what the whole flow is going to be. So I'll just copy the paste. I'm not doing any maths over here. Simply the code is anyways tested and we have already tried it. So I'm going to copy the paste. I'll just give a check if everything's fine. All the names are okay. Oh, I forgot I over here. Import. So the code looks fine. Then the configuration, device name. You check the device ID. Device ID should be ICU underscore monitor one mon1. This is the same name we need to use as a topic because we'll be publishing the message data from this device. So the name should be the same name. Alright, I'll save the file and come out of it. I'll go to another terminal over here and I'll start one more terminal window over here. The reason I'm going to do this is now I'll demonstrate how both the devices, monitor 1, ICU monitor 1 and ICU monitor 2, I'll start publishing the message using that Python code from both the devices, and you will see on the third terminal window on the left, the messages will start publishing in the form of JSON, and all the parameter values that we have defined, how it will start publishing the values over there. So let's have a look. Here I'm just subscribing to the topic. Now I don't want one topic, I want both the topics. So what I'll do is I'll use hash. Hash indicates that all the topics within this particular main topic folder device, I'm subscribing to all of those topics under device. So everything that I publish from any of the devices under this device folder will be displayed over there on the left side window, terminal window. So here I'll run ICU monitor 2. Oh, config.json is missing. We have to create the config.json file because if you remember in the Python code, we had created a file separately showing the body temperatures. So I need to create that config.json. So let me create that file and I'll just copy the contents from there. I'll VI into that. And here it is. We'll copy this into that file. That's it. We save it. Exit. I'll clear the window. So this is monitor 1. You see it is connected with the result code 0. Remember there are various result codes 0, 1, 2, 3. So 0 means successful connection. So we have connected successfully to our device 1. And if I run on the left hand side, you will see the messages will start publishing onto monitor 1 from the monitor 1 device. Now in this terminal, I'm going to run monitor 2. And you will see on the left hand side window, it will start publishing monitor 2. Oh, okay, sorry. I have not changed the code. I'll have to change the device name inside the code. I've kept it as device monitor 1 only. So I'll just change the device ID over here to mon2. That's it. Save, exit. And now I'll run that code. There you go. So we have connected, and notice on the left hand window terminal, you will see mon1, mon2 both getting published over there because we have subscribed it using hash. That means from all the topics within that device is getting published, the data and the messages are getting published over there. Notice the timestamp, it is a millisecond format. We'll see in the further videos, I'll try to show you how we deal with the timestamps when dealing with DynamoDB aggregation, if you have to do more analysis and aggregation. I'm going to exit or stop this over here, clear the screen. Now we'll see how we publish this data to DynamoDB. Now we are able to see the topics, the messages getting pushed into our MQTT brokers. Now we'll push these messages into DynamoDB. So we have already created the functions. I'm going to create a separate file to create the schema in DynamoDB with the name monitor ICU data, and we'll run that from over here to create the that schema on AWS DynamoDB. From this EC2 instance, we are going to create a schema that you will be able to see here in the AWS DynamoDB screen. I can show you over here. Go to DynamoDB managed services on AWS. And if I go here, nothing is there in the tables, right? I refresh and you see there's nothing, no tables found. There are no schemas over here we have created. So let's start. I've copied this JSON. You can see the table name, schema name is there. We have defined device ID and timestamp, which are the two partition keys and the sort keys. You need to read more on what partition keys and sort keys are in DynamoDB context. This is a NoSQL, so it's different from what normally we use as an RDBMS. So follow the same set of commands. So sudo apt install. So I'll be using CLI, which is a command line interface for AWS, so that I can use that command line interface to connect to AWS DynamoDB. So AWS provides you command line interface ability with a lot of commands. There are a set of commands that you can run, and anything and everything that you do from the AWS GUI screen, you have the ability to run and perform those operations through command line interface as well. And the reason of that is, if you want to automate this or you want to create your scripts or shell scripts, you can put these commands under that script and you can execute your script or schedule it as a cron, and you can define the schedules of those scripts that you want to run and execute the way you want it to function. So here I'm going to what I'm missing here. Let me check. I've used underscore or hyphen. Oh, I've used hyphen. So sorry. I have used hyphen in the file name. So I'll have to use hyphen. Let me modify the command itself. Change it to hyphen and now I run. So you must specify a region. So this is very important concept of AWS. It's very important that you mention which region this EC2 instance is running on. So we are on North Virginia, which is US East 1. So I'll mention that region. And there you go. So we have created this. Now we'll go here and you can see the schema is ready to use. There's no data now because we have not yet run the code from MQTT to Dynamo. And that is what we are going to see next. How we execute that Python script from our EC2 instance so that the data gets stored into Dynamo. Right now we have no data because it's all published into the topics, but from the topics nothing is getting published into the DynamoDB. So now let me create that file, mqtt to dynamodb.py, and create a file. I made a spelling mistake, I think. Oh, sorry about that, guys. Correct the name. I'll just copy and paste that code that we have locally developed onto this file on EC2 instance. Save, exit, and that's it. So it's running fine, and we'll go to DynamoDB, and there you go. You can see both the devices, ICU-Mon2 and ICU-Mon1. Both the data from both the devices are getting stored into Dynamo. So that's all for this session, guys. Thank you and have a good day.